All right, ladies and gentlemen, this is how to generate electricity 101. All right. In order to generate electricity, you basically need a barrel of some sort or a turbine, something round. All right, that'll roll. On one end, I'm gonna need you to put a positive magnet. On the other end, I want you to put a negative magnet. In the middle, I just want you to put some metal. Okay? Now, once you have those components, you have everything that you need to generate electricity. Now, let me tell you why. The way electricity is generated is you take a positive magnet and a negative magnet and you spin them. All right? You spin them around some metal. And what that does is that causes the positive electrons and the negative electrons to become excited. They become excited. They're so happy. They're running around, they're spinning, and this metal is drawing it towards them. So all these ions are being drawn towards the metal, and these ions are being drawn towards the metal. And when they meet in the middle, since they're moving, they create friction and heat. All right, that's electricity. Now all you gotta do is get a wire, connect that wire to a battery, and just save the electricity that you're generating by spinning that turbine. All right, so all you got to do is spin the turbine, and it's going to generate electricity. You save it, and then you sell it to people, and you get you some money. All right, that's how that works. Now, in order to mass produce this electricity so you can make a lot of money, all you do is you take that turbine, you put a propeller on it, and you stick it up on top of a mill, so that way when the wind blows, the wind will spin that turbine and it'll generate electricity. All you got to do is run a cable to a battery and save it and then sell it to people. Or another thing that you can do is you can take that turbine, you can put it at the top of a waterfall. All right, so that way the water going over the fall will cause the turbine to spin. And in that way, again, run your wire to the battery, generate electricity, save it, sell it to the public. All right, so that's how electricity is generated, ladies and gentlemen. Now, with that understanding, let's talk about the earth and the sun. All right, the earth. At the top of the earth is what they call the North Pole, and at the bottom is what they call the South Pole. Okay, pole is a term that's just short for polarity. So we got the positive polarity, and polarity refers to magnetism. So we got a positive magnet at the top of the earth, a negative magnet at the bottom of the earth. Inside the earth is metal, and the earth is spinning. All right, and by the composition of those things, the earth is generating electricity naturally. Now, the electricity that the earth is generating, see, it doesn't store it. It just goes out around the earth all the time, 24 hours a day, 7 days a week. It's generating electricity. All right, and when we are tilted at 23 degrees, the earth spins at a set rate. Okay, so that means that the earth is generating a particular amount of electricity when it spins at a particular rate and at a particular angle. All right. Now, the sun. All right. At the top of the sun is a North Pole, bottom South Pole, and the sun is spinning. All right. The sun is so big and it's spinning so fast that it's generating so much electricity, all right, that you can't even look at it. That's how much electricity the sun is generating. It's generating so much electricity you can't even look at it. And if you get too close, you're going to get burned up. All right? Again, the electricity that the sun is creating isn't just getting saved in a battery somewhere. It's spitting that electricity out 24 hours, 7 days a week. And that electricity is so much and so powerful, it's moving at 1 million miles per hour. Okay? That's called the solar wind, because the sun is generating so much electricity that is moving at 1 million miles per hour. All right? Now, if anybody has ever tried to put two positive magnets together, you know that you can't do it. They push off on each other. All right? So that means that when the electricity that's blowing off of the sun at 1 million miles per hour, okay, now the sun is so far away that by the time that electricity gets to us, all right, we're spinning at such a rate and we're generating enough electricity that by the time that electricity gets to us from the sun, it bounces off of the Earth's electricity. All right, so the electricity that the Earth is generating is causing the electricity that the sun is generating to bounce around us. See, it's deflecting it. It's like a force field that's protecting us from this. All right, now remember that the Earth is spinning because it's tilted. All right, so if you can imagine, on the day that the Earth reaches a 0-degree tilt, it's going to stand still. So on the day that the Earth stands still, we're no longer going to have this magnetic field. All right? And there's nothing that's going to be to block that 1 million mile per hour solar wind that's coming off of the sun. All right? Okay, here's out of the science book. It says the Earth's magnetic field behaves as if it were a powerful bar magnet located at the planet's core and tilted at a slight angle to the axis of rotation, 11 degrees at present. This field is thought to be produced by the swirling liquid of iron of the outer core, acting like the spinning conductor in a bicycle generator. All right. So again, they telling you that the Earth is spinning, and as a result, it's generating electricity. All right. All right. Here's another document. It talks about the Earth's magnetic field, and it shows right here. All right, the dynamic. It says, the magnetosphere shields the surface of the Earth from the charged particles of the solar wind and is generated by electric currents located in many different parts of the Earth. Alright? So this little dot right in here, that little speck, that's the Earth. All this stuff right here, that's the electricity that the Earth is generating. Alright? Now, as you can see, here's the sun, and this right here is the solar wind. This is the electricity that's blowing off of the sun at 1 million miles per hour. But when it comes to the Earth, since it's a positive force and this is a positive force, it just deflects and it goes around us. All right, you see that? Another scientific publication that discusses the magnetic field. All right, let's zoom in on this part down here. It says, if the convection stopped, or if the outer core solidified, the magnetic field would cease to be generated. Secular variations in the magnetic field have been well documented by examination of the paleomagnetic record in the sea floor, lava flows, and sediments. Every few thousand years, the magnetic field changes intensity and reverses, with the north and south poles abruptly flipping. Alright, so they just told you a whole lot right there. Alright, they told you if the convection stopped, the magnetic field would cease to be generated. Every few thousand years, the magnetic field changes intensity and reverses. Alright? Now, they show us tilted. Alright? So, when we hit that 0 degree mark, the Earth stands still, the convection stops. Okay? Then the Earth falls over, and the process gets started again because we're leaning again, so we start spinning again, except when we fall over this way, we spin in the opposite direction. So since we're spinning in an opposite direction, that means that the magnetic field would reverse, and that the North Pole would become a negative magnet, and the South Pole would become a positive magnet. So that's why they says that it abruptly flips. Abruptly. Not over the course of 26,000 years, abruptly. Like over the course of 7 years. Alright, if not even over the course of that one day.